Hi everyone, this is Janine Co, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt to the situation quickly. That's why we're offering and running free classes and they're daily for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will host an SAT prep. So this is going to be a mix of calculated questions versus no calculator questions. So let's get started. Can I get a yes if you can see my screen? Okay, cool. So for the first question, we have Stroker, Iceland's most visited active geyser, has flow rates that range from 0 to a maximum of 180 liters per second from a single spring. What is the maximum flow rate of Stroker? I believe this is pronounced a Stroker in centimeter cube per hour. And then we have this conversion, which is 1 liter is equal to 1,000 centimeter cube. So first, this is a dimensional analysis question or unit analysis. Therefore, you need to convert liters per second into centimeter cube per hour, right? So in that case, I tell my students that you need to start off with your given. So they're telling you that you have 180 liters per second, right? So this is your flow rate, and then this is going to be over second. And then because they're telling you that you have 1 liter and that's equivalent to 1,000 centimeter cube, that means you need to think about where you're placing your liters, right? So that you get to centimeters cube. So in that case, you need to have liters in your denominator, right? Over here because you wanted to cancel out liters and get to centimeters cube, right? And because they're saying that it's a direct conversion from liters to centimeters cube, then all you have to do is write 1,000 centimeter cube. Does that make sense? So it's a direct conversion. Now, we're not yet done because we need to convert seconds to hours, as you can see. So we know that for every 3,600 seconds, that's going to be 1 hour, right? So that's a direct conversion again. So in that case, we can cancel out liters and we get to centimeters cube. And then on the other hand, seconds can also cancel out and you can get 2 hours in that case. Okay, so for some of you that may think that, okay, so how can you say that liters cancel out with liters? Well, if you think about fractions, right, you're going to say that, for example, if you have, let's say, 2, right? So think about liters as a number 2, and then you're multiplying this to 1 over 2. So this is just me throwing away numbers to give you an example. So 2 times 1/2 is actually equal to 1, right? And why? Because the 2 cancels out by itself, right? 2 divided by 2 is 1. So that's what's happening right here if you have liters and you have liters over here. Same thing for seconds, right? So now we get to our this desired unit, which is centimeters cube and hours, then we stop, right? So take your calculator out. So you have to punch this in. So you have 180 times 1,000 times 3,600, right? And that's going to give you 648. And you have 3 zeros. Actually, you have 6 zeros, right? Okay, 180, then 1,000 times 600. Yeah, there's 6 zeros right here. And this would be in centimeter cube per hour, right? So in that case, that would be letter C. So that's your answer. Okay, cool. So it's actually 648 million, right? So that's the maximum flow rate of Stroker. And that's in centimeters cube per hour. right? Okay, so if you guys cannot see this, so here's my final answer. Great. So moving on to question 2. So we have a local ice cream shop that sells ice cream and tracks the total ice cream sales made during noon for the last 12 days as shown in the scatter plot below, along with a line of best fit. So this is your line of best fit for the data and an equation for the line of best fit. According to the line of best fit, what is the predicted temperature if the total ice cream sales is $378, and you need to round your answer to one decimal place value? So because they're telling you that you have a line of best fit, which is y is equal to 10.5x minus 496.5, and the total ice cream sale is 378. So let's say this is your predicted. Now you need to figure out what x is, right? Because x corresponds to your temperature. So all of your x values are basically temperature, and then your y is your total ice cream sales, and this is in dollars, right? So now you would have to plug in 378 as your y. So we're essentially using this line of best fit to find your temperature. So 378 is equal to 10.5, and this is times x minus 496.5. Okay, so as you can see, all we need to do is isolate x, right? So 378 plus 496.5, because you need to move this to the opposite side of the equation. So this is equal to 874.5. And that's equal to 10.5x. So dividing both sides with 10.5, you get x is equal to 83.23, right? So that would be 83.3. And this is in degrees Fahrenheit, right? So in that case, that would be B right here. Okay, so I think that was pretty straightforward. So we can move on to number 3. Okay, so here we have the data below shows the initial number of bacteria placed in growth medium at time t is equal to 0, and the number of bacteria in the growth medium over 3 hours. Which of the following functions best models the number of bacteria nt after t hours? Okay, so we have a couple of equations here, and as you can see, this is an exponential growth of bacteria, right? So if you have t is equal to 0, right, your initial number, so the number of bacteria you have initially, right, so let me rephrase that, that's equal to 1.0 times 10 to the power of 2. Because if you remember, we have your exponential equation being y is equal to a, right, your constant times b raised to the power of x. So your a is essentially your initial number of bacteria, and in that case we know that it's 1.0 times 10 to the power of 2, which is actually 100, right? So this is just expressed in scientific notation, and then we just have to move your decimal point, right, or multiply this to 10 to the power of 2, right, so we get 100. So that's our initial, right? So sometimes you call this a naught, right, in some textbooks, and then you have your b raised to the power of x. So that is your factor, right? So how do you find your factor anytime you're moving from time 0 to time 1 to time 2 and time 3 respectively? So all you have to do is find the ratio between 3.0 times 10 to the power of 2 over 1.0 times 10 to the power of 2. And same thing, right? If you're at time 2, you need to find the ratio between time 2 and time 1. And again, you're going to do the exact same thing from time 3 to time 2, right? So when you divide 3 times 10 to the power of 2 with 1 times 10 to the power of 2, you're going to get 3, right? Same thing here. If you divide 9 times 10 to the power of 2 with 3 times 10 to the power of 2, you're also going to get 3. And same thing for this one. If you divide 2 0.7 times 10 to the power of 3 divided by 9 times 10 to the power of 2. Let's try that. You're going to get 3 as well. Yeah. So as you can see, there is a common ratio, which is 3. That's why your b is going to be 3, and that's raised to the power of t, right? Because we're saying that your x is time, right? All of your x values would be time in that case. So that's why it's c. Okay. So I think that was not too bad. If we can move on to number 4. Okay, so for number 4, we have a polynomial p of x, and the value of p of 5 is equal to -1. Which of the following must be true about p of x? Okay, so if you recall, for polynomials, we have what you call the factor theorem and the remainder theorem. Okay, So factor theorem, and then you have the remainder theorem. So this is... So they're very similar. However, for example, if you're looking at the factor theorem, so for example, you have this, right? They're saying it's 5. We can say that this is going to be x minus 5, right? Because we know that x minus 5 is equal to 0. That would give you x is equal to 5. So in that case, we know that if you have x minus 5, right? And then when you plug in 5 to your polynomial p of x, right? You're going to get -1. So that means it's not going to be a factor, right? Because if you have 5 being a factor of this polynomial, you should expect that this would be 0. Because if you think about long division, right, or any type of division that you're doing, if something, right, maybe we can use, let's say, 6 as an example, and we know that if you have 6, we know that the two factors of 6, right, except itself and 1, right, we have 2 and 3 as a good example. If you're dividing 6, right, with 2, right, and if you're multiplying 2 times 3 to get 6, well, you don't really have any remainder, right? So if you're dividing 6 with 2, you don't have a remainder because you get exactly 3, right? So based on the factor theorem, if you have x minus 5 as an example, you should end up with 0, not -1. If something is a factor, you shouldn't really have any remainder, right? It should be 0. So that means when you're dividing p of x with 5, right? If you're getting -1, that means your remainder is -1. So that would be D, right? So if it's the factor theorem, right? If something is a factor, so let's say A is a factor, that means you should get 0. And if you're using the remainder theorem, right? If you have a polynomial and you're plugging in A, this should be any number. Does that make sense? So maybe I can just call this as X. Great. So, okay, x minus 5 is equal to -1. There we go. Hopefully that was pretty straightforward. This is nothing to stress about, I would say. Okay. So let's move on to number 5. So the histogram below shows the number of students aged 14 to 18 and their weekly earnings by 50 students from the same high school, which is Rolling Hills High School. In the histogram, the first bar from the left, so that this is here, represents all students who earn at least $10 but less than 20, right? And they've indicated that right here. The second bar represents all students who earn at least $20 but less than 30, and so on and so forth. Which of the following could be the mean weekly earnings in dollars for the 50 students? Okay, so they're asking for the mean weekly earnings, and specifically that's for 50 students. So as you can see, right, they've plotted a histogram, and for the first bar from 10 to 20, you have 7 students, right? Maybe I can just write this down. So here's the number of students that you have. And then for 20 to 30, you have 10 students. Moving on to $30 to $40, if you have The third bar, that's 11 students. And then from 40 to 50, that's 9 students. 50 to 60, that's 6. From 60 to 70, that's 5. And then you have 70 to 80, which is 2, right? So when you, first of all, when you try adding all of these numbers up, so maybe we can try that. So 7 plus 10 plus 11 plus 9 plus 6 plus 5 plus 2. That's going to give you 50 students, right? So it actually makes sense. So it's 50 students. And because they're telling you that anytime you have this bar right here, there is a limit, right? Because they're saying you can earn at least $10, but it's less than 20. So maybe we can say that for this bar right here, because you have 7 students, that means you're earning at least $10. That would be 70, right? Because it's 7 times $10 to give you 70. So for the total value, that would be $70 if you have seven students. And then on the other hand, if you have 20 to 30, we can just use 20 as your base because you need to earn at least 20, right? But it's not $30. Does that make sense? Because it has to be less than 30. So 10 times 20, that would be 200, right? For 10 students. And then for this bar, we have 30, right? Times 11. So that would give us 330, right? And then for this bar, we have 9 times 40. So this is 360. And then for this bar, we have 6, and this is times 50. So that's 300. And then this bar is 5 times 60. So that's 300. And then you have 2 times 70, right? So that would give you 140. Okay, so because they're asking you the mean weekly earnings, right? That means you're taking all of these weekly earnings and you're dividing that with 50 because you have 50 students. So maybe we can do that right here. So 70 plus 200 plus 330 plus 360 plus 300 plus 300 plus 140. So when you add everything up right here, you're going to get 1,700, right? And you need to divide this with 50, right? So when you divide this with 50, you should end up with 34, right? So that's A in that case. So mean is just another way of saying it's the average, right? So the average when you have 50 students. So that's the mean weekly earnings. Great. Okay, so moving on to number 6. Let me just see if we have some space at the bottom because I just realized I did not leave any space for us to solve. Because during the SAT, you do get student responses, right? So they're not telling you what the answer is, right? So it's not like it's multiple choice questions. So it's basically for you to tell them what the answer is, and you need to show your calculations. Okay, so maybe I can just do it up here, if you guys can see that, and I'll use a different color. Okay, so for number 6, we have City X, and this is in 2015. So City X had constructed 72 skyscrapers, and starting in 2016, City X has been building 5 new skyscrapers each year. At this rate, how many skyscrapers will City X have in 2060? Great. So they're giving us a couple of years to work with. So we have 2015. Basically, we have 72 skyscrapers. I'm just going to call this Sky S, okay, for skyscrapers in short. And then starting 2016, City X has been building 5 new skyscrapers, right? So the reason why I'm indicating N, right? So N being the number of skyscrapers each year, right? That's why I have 5 times N. Does that make sense? So each year, right? sorry, n is basically each year, starting from 2016, right? And so, for example, 2016, you would build 5 skyscrapers, and then 2017, that's going to be, right, times 2. So that's 10 skyscrapers that's built by 2017, and then moving on to 2018, so on and so forth. So n would indicate the number of years, right? Not the number of skyscrapers that's being built, because they're saying that it's 5 new skyscrapers each year. Okay, hopefully that makes sense. So you have 5n. And then they're asking you, at this rate, how many skyscrapers will City X have in 2060? So really, all you have to do is subtract 2060 minus 2015, right? So 2060 minus 2015, that should give you 45, right? So you have 45 years in between 2015 and 2060, right? So if you have 45 years, right, and we said that n is the number of years that you have, that means you need to multiply 45 times 5, right? So that would be 5 times 45, and that should give you 225, right? So by 2060, because you're starting at 2015 and you know that there's 72 skyscrapers, you need to add 225 plus 72. So that would give you 297 skyscrapers. Okay. So yeah, so for number 6, just bear in mind that I have my worked out solution starting from here, just so for the people who just came in, just wanted to say hi, and just so you know, my solutions are also like in here. Great, because we don't have enough space, as you can see. Okay, so moving on to number 7. Okay, so to edit the video, Emily charges $150 for the first 3 hours and $70 per hour after the first 3 hours. Which of the following expresses the amount? C, in dollars. There should be an if here. If Emily charges... Okay, this should not be here. Okay, sorry about that. Which of the following expresses the amount, C, in dollars, if it takes her X hours to edit a video where X greater than 3? Okay, so because they're saying that it's $150 for the first 3 hours, right? So we can just say C is C of X, right? In that case, because it's a function of X. And they're saying that you need to pay $150 for the first 3 hours. So no matter what, you're paying $150, right? If you're interested in her service. So that means you have 150 right here, and this is going to be plus 70. So now here's the thing, because they're saying that and $70 per hour after the first 3 hours, that means you need to have X minus 3 as opposed to X, right? So you can't say it's just X, because that means you're taking away the 3 hours or the initial 3 hours because you're paying 150 for that. Does that make sense? So that's why it's not just times X, because I think a lot of students, they tend to just write times X as opposed to X minus the number of hours that were originally paid or initially paid. So just bear in mind that you need to have X minus 3. Because if you think about it, you're already paying $150, right, for the first 3 hours. So you don't need to pay for the first 3 hours. That's why you're getting rid of that minus 3 right there. Okay, so you have 150, and this is basically plus, right, 70x. So you just need to apply the distributive property. And then you have 70 times negative 3. So this is negative 210, right? So 70 times negative 3, that would be negative 210. So 150 minus 210, okay, that's negative 60, right? So it should be B. So this is 70x minus 60. Great. Okay, so that's it. That's for number 7. Okay, so for number 8, it says an architect uses the function c defined by c of x, which is equal to 20x plus, and this is 40,000, right? To estimate the cost in dollars to build a 2-story home of planned floor area of x square feet if the architect estimates that the cost to build a certain 2-story home is $200,000. What is the planned floor area in square feet of the 2-story home? Okay, so there's a lot of things going on here. Basically, they're telling us that you have a function, and then that's in dollars, right? So we know that c of x is the amount, right? That you need to pay, and then x is basically the area, right? So now, well, the architect is telling us that, let's say you want to build a 2-story home and it costs approximately $200,000, right? Now they're asking you what is x, right? If it's $200,000, if that's the cost, what is your planned floor area? So what's x, right? So all you have to do is plug in $200,000 in c of x. And that's going to be equal to 20x, and this is plus 40,000. So yeah, we just have to solve for x, right? So 200,000 minus 40,000. So that's going to give us 160,000, right? And we have 160,000 divided by 20 just to solve for x, right? So x should give us, so divided by 20, that should give us 8,000, right? So it's 8,000 in square feet. As you can see, because they're telling us that x is in square feet, we don't really have to change the units here, so we can just keep it consistent. Great. Okay. Okay, so moving on to number 9. This is going to be a long one, actually, for number 9. So we have George buying a pair of shoes and a school bag at a department store. The sum of the pair of shoes and the school bag before sales tax was $120. So before sales tax, the cost of both items is $120. And then there was no sales tax on the shoes, but 13% sales tax was applied to the school bag. The total George paid, including sales tax, was $128.50. There should be a dollar sign here. What was the price in dollars of the shoes? Great. So there's 2 equations that you need to come up with. So the first one being before sales tax, right? So let S be shoes, right? So we're going to call this S for shoes because we need to come up with the equation. And then for the school bag, because they both start with S, in this case, we're just going to say that the bag would be B, right? So S for shoes and bag for B. So before sales tax, it's $120, right? So S plus B is 120. So we can just drop the 00 right here for the cents. And then they're saying that for the next one, well, there was no sales tax on the shoes, but for the bag, it's 13% of whatever the cost is for the bag, right? And then they're saying that the total George paid, including sales tax, that's going to be 128.50, right? Okay, so a lot of students, what they do, they just write S plus, because we know that this is 13%, this is 0.13, right, in decimal. This is what typically students do. They would just write S plus 0.13b, right? That's actually wrong because you're saying that this 0.13, you're not really paying for the total amount, right? So initially, remember, if we recall, so this is wrong. Initially, if you recall, that we're paying for the bag, and we know that the bag costs the whole thing, right? So you're paying the whole amount for the bag, which is 1, right? So we can say this is 1. And then we're saying that because you need to pay 13% of whatever the amount is, or whatever the cost is for the bag, that's going to be 0.13 of that, right? So technically you're paying 1.13 of the amount, right, of the cost of the bag. Does that make sense? So it's not just 0.13 of B, it's actually 1 plus 0.13, which is 1.13. So this should be S plus 1.13B. So that's how you formulate your equation. Great. So as you can see, because we can isolate S, right? So we can actually apply substitution here. So this is a system of linear equations, right? Remember that concept. Basically, you can either apply elimination or you can apply substitution. I'll go ahead and just apply substitution. So we have S right here. Maybe we can isolate, let's see. Let's just isolate S from here. So we have S, which is equal to 120 minus B, right? And then because we're seeing S right here, we can just plug in your 120 minus B over here, right? So this is 120 minus B plus 1.13B. That's equal to 128.50. Great. So we have 1.13B minus 1, right? And then that's going to be it's 0.13B, right? So this is 0.13B, right? So these two are like terms, right? This and this, right? So 1.13 minus 1 should give us 0.13B. And then you have 128.50, right? Minus 120. And that's equal to 8.5, right? So isolating B, you would have to divide both sides with 0.13. So B is equal to 65.38, right? I know technically you don't really pay 38 cents. You would just have to round this into 40 cents. Okay, but let's just keep it as 65.38 for now. Okay, great. So we have the price of the bag, right? And this is actually before sales tax, right? Because it's just B is equal to 65.38. Now, because you need to find the price in dollars of the shoes, right? All you have to do is plug in 65.38. You can either plug that in your first equation, which is this, or you can just plug this right here, right? Because essentially you're still going to get the price of the shoes, right? So I'm using equation 1 because this is the easiest equation that I can see, right? You don't really have to multiply anything with 1.13. So I'm using equation 1, and then I'm isolating S, right? So this is plus, and you're seeing B right here, so that would be 65.38, and that's equal to 120, right? So 120 minus 65.38, that's equal to 54.62. So we know that the price of your shoes, right, the pair of shoes, is 54.62. So that's going to be A. Again, typically we would pay 54.60, right? But just so we can be exact in terms of rounding, and because one of the options gives us 54.62, right? We're just going to keep it as 54.62. And this is in dollars. Great. So moving on to number 10, so we have line L and its graph in the XY plane below, which is right here. Can you guys see that? If line L is translated 3 units up and 5 units left, okay, let's use a blue pen just to distinguish the difference between number 9 and number 10. So we have 3 units up and 5 units left. What is the new slope of line L, right? So here's the key word, right? They're saying it's translation. So that means the slope would be the same, right? Because you're only translating, you are not transforming the function, right? So if you have 3 units up, right? So let's say you have your y-intercept here, which is 5. If you're moving this 3 units up, that would be 6, 7, 8, right? So your point is going to be right here. So that's 8. So that's 1, 2, 3, 6, 7, 8. And then you're translating 5 units to the left, right? So that would be, let's see, somewhere here, right? So that would be 5 units left. Okay, so because we're right here, okay, so because we're at 5 and it's exactly the same 5 units, that means it's going to be back to the origin, right? So instead of having it right here, right? If you don't, so let's say they're just saying it's 3 units up, right? And then you're not really translating to the left 5 units, then you know that your graph is going to be right here, right? However, because they're saying that you're translating 5 units to the left, it would be somewhere here. Does that make sense? So your slope is not really going to change, therefore, it's going to be -1, right? And how do you know your slope is -1? Well, if you're looking at 5, right? Rise over run. So we know that this is a negative slope because it's at quadrant 2 and quadrant 4, right? So that means this is -5 over 5. So that would be, yeah, -5 over 5. So this is -1, right? So, and the new slope is still going to be -1. That's why it's C. Okay, so let's see. Yeah, you don't really have to draw the, I guess, line here, the new line, because essentially because they're just telling you that it's translation, then you don't really need to find the new slope, right? Because you know if it's translation, you're just really okay, so imagine this, you're taking your line and you're physically lifting it and then you're moving it 3 units up and 5 units left, right? So it does not change the slope. Does that make sense? Because it's not transformation. Great. So for number 11, okay, so we have after school, Tina swims at 1.2 miles per hour and rides a bike at 11 miles per hour. And her goal is to swim and to ride her bike at least 10 miles in no more than an hour. If Tina swims S miles and rides her bike B miles, which of the following systems of inequalities represents Tina's goal? Okay, great. So they're telling us it's 1.2 miles per hour and then you have 11 miles per hour, right? So that means when you set up your equation, you need to have your B and your S in your numerator, right? Because you're telling your, okay, hold on. So they're saying that it's S miles and it's B miles, right? So S is basically your unit for swimming, which is in miles, right? And then you have B, which is your unit for biking, right? And this is in miles. Because they're saying it's 1.2 miles per hour, right? They've indicated that hour is in the denominator, and then you have 11. So this is miles per hour, right? So that means you know that your unit, right, S, needs to be in your numerator, right? And then this is going to be 1.2 in your denominator because this includes also your time, right? It's per hour, remember? So that's why you have that right here. And this has to be less than or equal to 1 because they're saying that it's in no more than an hour, right? And then on the other hand, because they're telling you that her goal is to swim and ride her bike at least 10 miles, right? You need to have this equal sign because you need to at least hit that 10, right? And you can go beyond 10. Does that make sense? So that's why it's greater than or equal to 10. And also, the reason why you have less than or equal to 1 right here, it's because when they're defining in no more than an hour, right, you cannot go past 1 hour, but you can actually hit 1 hour exactly. So that's why it should be A. Okay, so for number 12, hopefully that makes sense for number 11 before we proceed to number 12. Okay, as a reminder, everything is recorded, so you don't have to quickly jot the questions down because they will be available at your convenience after the session. Okay, so for number 12, we have the graph of line D is shown in the xy plane below. Which of the following is an equation of a line that is perpendicular to line D? Great. So here's a keyword. It says you need to find an equation of a line that is perpendicular to this line, right? So first, what do we know about perpendicular? If something is perpendicular to line D, right, or whatever line you have, remember, just go back to algebra, right? Algebra 2. Basically, for something to be perpendicular to a line, you need to look at its slope, right? Because for the slope, if you have, let's say, okay, let's calculate the slope of line D for now. So we know that this is rise over run, right? So this is -6/3, right? And this is actually -2, right? So the slope of line D is actually -2. So that means in order for you to figure out whether something is perpendicular to line D, you need to have the reciprocal, right? So you take the reciprocal of the existing slope. So you have m is equal to -2. Therefore, for something to be perpendicular, you need to have a slope which is 1/2, right? Does that make sense? And it has to be the opposite sign as well, right? So you flip the sign, right? We know that this is negative, so you flip that into a positive sign. And then you take the reciprocal of your existing slope, right? So we know that the slope of D is going to be -2, right? So that means for this to be perpendicular, if you have, let's say, part C, right? Because all of the slopes here, as you can see, this is m is equal to 2 for part A. For part B, this is m is equal to -2. And then for part C, we see that this is 1/2, which is exactly what we're looking for, right? And then for this, we know that this is m is equal to -1/2, which is what we don't really want. And there should be an x here, by the way. Yeah, so this is -1/2, right? But then we don't really want this because it's not the negative. It's a negative sign, right? So it's not positive. Therefore, we want C. Okay, so let's say if we want to really prove that this is perpendicular to our existing line, then that means you would just have to graph this, right? So this is 1/2, and this is basically an intercept of 1. So y-intercept is 1, and then you have slope, which is rise over run. So you go up by 1, so that would be 2, right? And then run would be, so this is 1, 2, 3, right? So rise by 1, right? This is now 2. Run is 1, 2. And then you have it right here, right? As you can see, your line would sort of look like this, right? So it is perpendicular, right? And why is it perpendicular? Because it forms a right angle when it intersects line D. Okay, so that's C. So it doesn't really matter what your y-intercept is or your b value is, right? Because it's y is equal to mx plus b. All that matters is your slope. It has to be the opposite sign, and it has to be the reciprocal of your existing slope. That's what it means when it's perpendicular. Because we're on this topic right now, if it's parallel, right? What if the question asks you, what is the line, or what is the equation of the line that is parallel to line D? That means you're going to find the exact same slope, right? Because if a line is parallel to line D, right, and if it's parallel, that means you need to have the exact same slope, right? So it would have a -2 slope as well. So you can actually say that B is parallel, right, to line D, right? Because it has a slope of -2, which is exactly the same slope for line D. Okay, great. So we have number 13. Okay, so we have in the circle below, line segment AB is the diameter, right? So we have that right here. So this is a line segment, but then this is your diameter. And then it says if the length of arc ACB, so this is your arc, right? ACB, right? By the way, AB is, this is your diameter right here. Because it's going to be, remember, because half of a circle, right, it's radius. Therefore, if you have a line segment AB from this point to this point, right, that's your diameter. And then they're saying that if the length of arc ACB is 6 pi, right, so ACB, so half of your circumference, right, is 6 pi, right? That means it's from here to here. Maybe I can highlight this as blue. So from this point to this point, that's basically 6 pi, right? That's what they're telling us. What is the length of the radius of the circle? And first of all, we don't really know what the diameter is, so we can't just say that it's divided by 2 and then we get the radius, right? So they're asking us what the radius is. Okay, so if you recall, right, if you have an arc, which they're telling us it's ACB, and it's basically half of your circumference, right? That means you can just multiply 6 pi by 2, right? To give us that entire circumference, right? Because the formula of your circumference, we know that, so C being circumference, this is 2 pi r, right? That's the circumference of a circle. So all we have to do is multiply 6 times 2, which is 12 pi, right? And then we have 12 pi over here. We plug in 12 pi in your circumference, and then this is going to be equal to 2 pi r. Dividing both sides with 2 pi, this should give us 6, right? So r is equal to 6, which is b. Does that make sense? Right? So we have to just double that because it's half of your circumference. And by the way, what's the circumference? Your circumference is basically sort of your perimeter that encompasses your circle outside. So it's exterior, right? So you're going from this way until you get to A again. Okay, so for number 14, what is the solution to the equation below? So we have 8 times 1 over 5 minus x is equal to 8 over 9 plus 12x. So yeah, all we have to do is solve for x, right? So here's the part where I don't want you to use your calculator because I want you to really practice on solving x manually, right? Because a lot of students, I know they rely on the calculator so much that sometimes they forget, I guess, the most basic parts in solving fractions. So that's what we're going to do today. So no calculators for this part. So we have 8 times 1 over 5. So this is going to give us 8 over 5, right? And then, as you can see, because we have a parenthesis right here, you need to distribute 8 to each of your terms, right? So 8 times 1 over 5 and 8 times negative x. So that would give us negative 8x. And this is equal to 8 over 9 plus 12x, right? As you can see, we have this 8x right here, or negative 8x rather, and then you have 12x. So maybe we can move 8x to the opposite side of the equation, right? And then we move 8 over 9 to the side of the equation. So 8 over 5 minus 8 over 9, and this is equal to 12x plus 8x, right? So that's 13, 14, 15, 16, 17, 18, 19, 20. So that's 20x, right? And yeah, so we have 20x, and basically we have a fraction right here, which is 8 over 5 minus 8 over 9, right? If you recall, this is from middle school, right? How would you combine fractions, or how can you subtract or add, right? Because subtraction and addition have the same rule. So how do you subtract the fractions, right? So remember, you need to find the least common denominator. So that means for 5 and 9, right, you can think about a number that is a multiple of both 5 and 9, right? So you can combine the two. So maybe 45, right? 45 is both a multiple of 5 and 9. So you can have 45 and minus 45. So the common denominator between 5 and 9 would be 45, right? So remember how this, right, times a number would give us 45, right? So this is 5 times 9 essentially to give us 45. So that means you need to multiply 8 times 9, which is 72 right here. And then on the other hand, because you know that this is 9 times 5, right, which is 45, that means 8 times 5 is 40, right? So that's how you turn it into the same denominator. And that's going to be equal to 20x, right? So 72 minus 40, right? And that's going to be 32, right? So this is 32 over 45, and this is equal to 20x, right? Dividing both sides with 20, you have 32 over 45, and because you're dividing, right, that means you're going to take the reciprocal. Remember the rule for fractions when you're dividing this by 20? This is going to be times 1 over 20 now, right? By the way, this is 45. It looks like it's a 9. 45. There we go. Okay, so now this is times 1 over 20, and that's equal to x, right? So we can simplify, yeah, we can simplify 32 and 20, right? Divide both sides with, let's see, maybe 4, right? If we divide 32 with 4, we're going to get 8. And then if we divide 20 with 4, we're going to get 5, right? So as you can see, everything has been simplified, right? That means 8 times 1 is 8. And you have 45 times 5, right? Let's just do a quick math here. 45 times 5, so that's 25. And then you have 4 times 5, that's 20, plus 2, 22, right? So it's 225. And that's equal to x. Therefore, our x is equal to 8 divided by 225. Great. Okay, so maybe let's move on to this question number 15. So we have how many solutions x, y are there to the system of equations below. So as you can see, you have 5x plus 25 is equal to 4. And then you have negative 5y, which is equal to x minus 2, right? So if you rearrange equation 2, so let's label this as equation 1 and this as equation 2. When you rearrange equation 2, you're going to get, let's see, 5. Yeah, so if you move negative 5y to the opposite side of the equation, you're going to get x, right, plus 5y. And then because you're moving this to the opposite side, that becomes plus 5y. And as a result, this negative 2, when you move this to the opposite side of the equation, you're going to get positive 2, right? And then because you want to, solve for x or y, right? Because this is a system of linear equations. Therefore, you need to multiply this equation 2 with a common multiple, right? That means when you multiply this to 5, right? Yeah, if you multiply this to 5, you're going to get 5x, right? Which gets rid of the 5x, right? If you subtract the 2. So maybe we can write that. So we have 5x plus 25y, which is equal to 10, right? So what I did was I just distributed 5 to each of my terms, right? So multiplying 5 times x would give you 5x. Multiplying 5 times 5y would give you 25y, and multiplying 5 times 2 would give you 10, right? So as a result, we can actually say that 5x plus 25 is equal to 4, right? So I'm taking equation 1, and I'm subtracting that from 5x plus 25y is equal to 10. Can you guys see that? So as you can see, 5x minus 5x cancels out, and then you have 25y minus 25y. It also cancels out, right? So this is actually 0, and you have 4 minus 10, which is negative 6, right? And we know that this is never true, right? Therefore, you don't have any solutions. That's why it's A. Okay, so we're almost there. Couple of things. So we have 16 and 17. Right, so if we look at 16, now here's the tricky part. They're giving us 3x minus y is equal to 12. And it says, what is the value of 27x over 3y, right? And by the way, for number 16, try not to use your calculator because I want you to remember all of your exponent laws, right? Oh, and also, if you notice, I know from my end, from my screen, you have 27, and the 12 looks like it's a subscript. It's supposed to be an exponent. I think it's just because the software just transforms it into a subscript, but when I was making this question, it's supposed to be an exponent. So just keep in mind that these are exponents, right? 12, 12, and 2. Okay, so we have 3x minus y is equal to 12, and it says, what is the value of 27x over 3y? By the way, this is x and this is y. Great. So because we have y here, maybe we can turn everything into the same variable, which is x, right? So we're going to have 3x, right? So essentially we're isolating y from the first equation, right? So we can just say this is 3x minus 12, which is equal to y. Can you guys see that? Okay, so I'm moving 12 to the opposite side and I'm moving negative y to the opposite side, right? So I can have 27x, right, over, and this is going to be 3 raised to the power of 3x minus 12. And by the way, what do we know about 27x? We can actually write 27 as the base of 3, right? So when we write 27, we're going to have 27 being expressed as 3 raised to the power of 3. Then you multiply this to the power, which is x, right? And then this is going to be over 3 raised to the power of 3x, right? Minus 12. And if you recall for exponent laws, right? What did we say about having subtraction, right, as part of your exponents? We can write this again, right, in terms of 3 raised to the power of 3x over 3 raised to the power of 12, right? Because if it's subtraction, you can actually divide the two, right, with the same base. So you can cancel this out and this out because you're dividing the two, and you end up with, first of all, this is going to be 3 over 3, right, which is 1. And then you're going to see that this is 1 over 3 raised to the power of 12, right? Actually, maybe I can show you the entire step just so it's easier. Okay, so we said this is 3 raised to the power of 3x over 3 raised to the power of 3x. And then you know how this is divided by 3 raised to the power of 12, right? When you have 3 raised to the power of 3x, you can actually just multiply this and just have 3 raised to the power of 12 over 3 raised to the power of 3x, right? Because essentially you're taking the reciprocal of this, right? So it's, instead of having, 3 raised to the power of 3x divided by 3 raised to the power of 3x over 3 raised to the power of 12, essentially I'm taking the reciprocal, if you can see. So I'm flipping this and this, right? So the position of these two are going to switch, right? Because you're taking the reciprocal and then you're multiplying the two, right? So you can cancel this and you can cancel this so you get 1 essentially, and then you're left with 3 raised to the power of 12, which is B. Great. Okay, so maybe to go over number 17 just as just to end this class off, right? Okay, so first of all, for number 17, you know that this is 26, right? If you recall, you have vertical angles in geometry, which means that if this is 26, right, you call this your, or actually I like to call this as your X pattern, right? Can you see the X pattern right here? So this is your X and this is your other line intersecting the line of X, right? So this is 26, this has to be 26, right? And if you look at this part, right, this is actually supplementary angles, right? This and this, they're supplementary angles, meaning the angles add up to 180 degrees, right? So 180 minus 104, right, therefore, would give you 76 degrees, right? So this is now 76 because you know that this is a straight angle and these two angles need to add up to 180 degrees, right? So in order to find this angle, right, that means you would have to subtract 180 because it's a triangle, right? So 180 minus 76 minus 26 should give you 78 degrees, right? So if you know that this is 78 degrees, because these two are supplementary, right? X degrees and 78 degrees are supplementary angles. Therefore, you need to subtract 180 minus 78 degrees, and that's going to give you 102. Okay, great. So that's how you're going to solve for number 17. Hopefully this is clear, and you have a couple of options here, but they're not the answer. So great. Yeah, so thank you so much guys for tuning in. Happy Sunday, and I hope this helped. If you're interested in having more classes with me, so we have oneclass.com/livestream. So this is where my schedule will be posted, and this is on a daily basis. Again, I'm hosting classes for both math and chemistry, so if you're interested, just check out this schedule. So oneclass.com/livestream. And if you do have any friends who you think might benefit from this, please call or text them and ask them to join. And I'll see you on my next class. Bye, guys.